This is the Liberator. It walks. It navigates. It does this and this, unfortunately. But most importantly, it looks damn cool. Let's go back a little bit to see how we got here. Previously, I built the endoskeleton. Then I struggled a little bit with reinforcement learning. So I settled on inverse kinematics for a predetermined gate. Now that I have a working base, it's time to turn this thing into the Liberator. My goals for this video: implement sound effects from the game, add an auto object avoidance feature, and paint the outer shell. Oh yeah, and finish this damn thing. This project has had no respect for my time. First up, the sound effects. I'll be using the speaker and sound card adapter from Waveshare. At this point I wasn't sure what kind of sound device I wanted to use, so I didn't have a mount ready to go. I ended up designing this piece in Fusion and glued it onto the component platform.
You've gotten a lot farther than you should have, but then you haven't met Frank Horrigan either. Your ride's over, Mutie. Time to die. Unless you like, comment, and subscribe within the next 10 seconds.
Now for the audio files themselves, I thought I'd actually have to purchase Fallout 76 to extract these sound effects, but thankfully the wiki has them ready to go. It had the taunts, voice lines to enemy combatants, death voice lines, and attack lines. And for the implementation, I made it so that every time I gave the forward command, it would pull a random attack audio and have it play a random taunt every 30 to 60 seconds. I might tighten this up so it's more frequent, but this is what it is for now. Now this is all well and good. I have sounds, I have a walking robot, I could just slap the shell on and be done. But I wanted to add some kind of navigation or basic obstacle avoidance to it. To achieve that, I'm going to use this. It's an HCSR04 ultrasonic sensor. One side emits a sound wave and the other side receives the echo of that same sound wave. Using an assumed value for speed of sound and the amount of time it took for the echo to return to the receiver, we can calculate the approximate distance of an object. With this sensor installed, we can make it so that the robot will turn or avoid obstacles that are a certain distance away. The logic for my obstacle avoidance program is pretty simple. Once the sensor picks up an object that's within 200 millimeters, it'll turn and it'll keep turning until it's in the clear. This will definitely work the first time with no issues. So here I've set up a little obstacle course, a chair with a backpack leaned up against it. So all I have to do is hold the Y button for about 3 seconds, then let go, and we're off. So we see it successfully detects and avoids the first and only obstacle. But we can see here that it's struggling with this corner. Pretty much deadlocked in this corner. So what I'm going to do is make sure that it turns only in one direction before it's in the clear, and that it backs up after a couple of attempts. So the shell went through a couple iterations. Here you can see a more elongated one that's more accurate to the game, but it's extremely heavy and it's weighing down the robot quite a bit. After that, I tried using the same material, but making it a bit shorter, but still a little too heavy for the robot and these servos and causing a lot of sag. So how do we get it to this point? Lightweight PLA was the solution. Because of its ability to foam up during printing, it has incredibly low density, making it around 30 to 50% lighter than standard PLA prints. And after more than 2 full days of printing, we had this bad boy right here. Before we paint it, I want to give a big shout out to PCBWay. I do not have the money for a resin printer, so PCBWay services came in clutch. They don't only provide 3D printing services, they provide PCB assembly, CNC machining, injection molding, and many more. Now it's time to paint the shell. It looks like The Last of Us out here. First thing I'm going to do with this paint job is lay on this automotive primer real thick. Since this PLA is very low density, it's very porous, so it's going to absorb a lot of the primer. And I'll do the exact same thing with these leg pieces here. And now I'm going to hit it with this bluish, tealish color here. I'm not really that great at mixing paint, so I just tried to find whatever colors match the actual robot as best as possible. And the same thing with the main shell. Forgot to record myself painting the darker tone, but all materials will be in the description below. Here I'm using this Duplicolor Perfect Match Universal Chrome to paint on some wearing and scratches. I added some chrome paint to this piece of paper towel, and now I'm adding some streaks to parts of the robot I think would have some wear and tear. And I did the same thing for the legs here too. And now we can finally install the shell itself. I didn't show it, but I have heated inserts in the flange parts of the component plate, and that's what I'm screwing into right now. And the last of the important parts I need to add is the star. We've also got a compartment for a 5mm LED in the back of the star. And with that, Liberator is now complete.